Note 6.5, rotations. Now you can notice that the size of my screen, I had to shrink it down a little bit because we're going to have to do something kind of interesting with your notes packet, and therefore I'm going to have to demonstrate it with the Smart Notebook software. I'm going to have to rotate the screen. So in order for me to do that effectively, I had to shrink it down a little bit. Okay. So before we get started, let's take a look at what rotation means. Okay, rotation is just a turning. Okay, and we always give a direction in which direction we're turning. So which way is clockwise? So if you think about how the clock works, okay, it goes, and we'll put a little arrow on that, goes in the direction of the clock. All right, goes to the right. So then which way is counterclockwise? Obviously the opposite of that. We'll put the arrow to indicate that direction for counterclockwise. So in this box here I've summarized, it says steps to graphing rotation, multiples of 90. Okay, so a 90-degree rotation is a quarter of a turn. Then if you think about a multiple of 90, let's add 90 plus 90 and get 180. So 180 degree rotation. Okay, that's half a turn. Okay, some of you that are skiers might think about that. I know probably there's some other sports out there that you do some rotations with. So 3/4 of a turn, or 270 degrees, that's 3/4 of a turn. And then a full 360, that would be 4/4, or one whole turn. Okay, so how are we going to do this? So we're going to have to obviously draw the original picture. Then we're literally and physically going to turn the paper in the direction and the amount that it's telling us to. Now the key here that I have written in bold, it says do not graph the coordinates when the paper is turned. Okay, and I'm going to put another couple stars by that. Determine what the new coordinates are while the paper is turned. And I'm going to demonstrate. And again, do not graph the coordinates when the paper is turned. Then we're going to turn the paper back to the original upright form that we look at our paper in, and then we're going to graph the new coordinates. So we've got this as a summary. Now let's demonstrate what all of those steps mean. Okay, so my first problem says given rectangle ABCD with coordinates A through D, and I have graphed the original for you. Now I want to find the new rectangle A prime, B prime, C prime, D prime after a 90-degree clockwise rotation. 90-degree clockwise rotation. So a 90-degree turn, this is where we're going to have to turn our paper. Okay, so a 90-degree quarter turn. So you're going to take your paper and you're going to do exactly what I'm doing. You're going to turn it a quarter turn. Okay, so now I'm not going to write anything because obviously I can't write anything because I've literally turned my paper, turned the screen here. But let's look at this rectangle. What would be the new coordinates when I turned my paper? Now I said don't write anything, don't graph anything. So what you're going to be doing is you're going to be writing on a scrap piece of paper, maybe over to the side. So what are the points of A? Okay, what are my points of A? So my new points, when I turn my paper, how would I get to this A down here? Because that's my rotation. A would be 4 to the right and 2 down. So A prime, you're going to call 4, -2. Write it on your scrap piece of paper. Because then when we turn the paper back, then we're going to write it on our notes. So what would B be? B would be 4 to the right and 5 down. So B prime, on your scrap paper, B prime, 4, -5. What would the new C be? C would be 2 to the right and 5 down. So C prime is 2, -5. Put it on your scrap paper. And D prime would be 2 to the right and 2 down. That's 2, -2. Okay, so you should have 4 coordinates written on a scrap piece of paper. Now I'm going to flip my paper back around, and you're going to turn it right side up, just like I did. And now let's put those coordinates on our paper. So A prime is 4, -2. Okay, we're just transferring these from our scrap paper. B prime is 4, -5. C prime is 2, -5. And D prime is 2, -2. Now, let's see if I can undo that. I don't know why I was grabbing it. There we go. D prime 2, -2. Now let's go to our graph and graph those points. Okay, so we're at 4, -2. Label it. B prime 4, -5. Label it. C prime 2 to the right, 5 down. And D prime 2 to the right, 2 down. Grab your straight edge and draw in your rectangle. Now look at it, examine it. Does it look like it has been turned counterclockwise a quarter of a turn? Okay, and you should say yes, it has definitely been turned a quarter of a turn. Okay, so let's look at example 2. So this one should go a little bit faster. We have the same rectangle, but now they're asking us to do a half turn with it. 180 degrees is a half of a turn. Okay, so let's do exactly that. So you ready to turn your paper? We're going to turn it a half turn. Okay, so essentially we're going to turn our paper upside down. Okay, so there's a quarter of a turn. There's your full turn. Okay, and I got to slide my paper up, and let's see if I can read my points here. I'm going to change colors. Okay, this doesn't work great with my technology, but get your scrap paper ready, and let's see what these points are. I don't want to erase this because this was part of our notes. If I look at A, now you've got your paper upside down, who can tell me what A prime is? So to get to A, we're going to go 2 to the left and 4 down. So you should write on your scrap paper, because we got our paper upside down, -2, -4. B, let's see where B is. B is -5, -4. Write that down. -5, -4. C is -5, -2. And D, 2 to the left, 2 down, that would be -2, -2. So you should have your 4 new points written on your scrap paper. Now turn your paper back around. Okay, and now let's put those 4 new points down on our paper, and then we'll plot them, and then we'll look to see, okay, does that figure, our new figure, look like it has been turned upside down? Okay, so the key is you got to have that scrap piece of paper handy so you can sort of take some notes because your paper is currently in a different orientation. Okay, then we're just transferring. Now let's go ahead and plot this new rectangle. So -2, -4, -5, -4, -5, -2, and -2, 2. Okay, connect. You should be using a straight edge. Okay, does that rectangle now look like it has been turned a half a turn? okay, or 180-degree rotation clockwise. Okay? All right, go ahead, flip the page. We got one more to do, and hopefully this one will go even faster. Okay, same rectangle, but we're just changing it, and now we're going to do 270 degrees rotation clockwise. Okay, 270 clockwise. So we're ready to turn our paper. You got your scrap paper ready, hopefully. Let's see if I can find my little rotation device. Okay, 270. Ready to walk this through? There's 90. There's 180. That's upside down. Now we got to turn it 270. There's 3/4 of a turn. So let's examine this rectangle. Get your scrap paper ready. So A prime is going to be -4, 2. B prime, -4, 5. C prime, -2, 5. And D prime, -2, 2. Okay, so go ahead, turn your paper back to the direction, the proper direction, and transfer those points from your scrap paper onto your notes. Okay, this is really important that you're doing this, okay, just like I'm doing this, especially right now as you're taking the notes. Practice that turning the paper, writing down what the coordinates are on a scrap piece of paper, and then transferring them to your notes or your work, and then going to the graph. So -4, 2, -4, 5. Whoops, I gotta go up. -4, 5. There we go. -2, 5. And -2, 2. So once you connect that, that new rectangle should look like it has been turned. Remember, clockwise, 270 degrees. Okay? So our little summary here, okay? Clockwise, 90 degrees. That was our first one that we did. So in general, what's the rule? I don't like to memorize these rules because I mix them up. That's why I have you guys turn the paper and physically do it that way. Because memorizing rules, we're bound to mix them up. So, but I'll tell you them. Y -X. And I'm a memorizer, but these always play with my head. Clockwise, I'm going to use those little diddle marks so I don't have to write the word clockwise again. 180. What happens to my point? My point becomes -x, -y. And then what about clockwise 270? Your point becomes -y, x. Again, you don't have to memorize these as long as you know the trick. Turn your paper, write it down on scrap paper, turn it back, and write it. I'm going to have you look up these properties. And then I would say even for some bonus points, okay? I don't give out extra credit, but for some bonus points, maybe some extra homework points, don't tell your friends, okay? You look them up for yourself and tell me. I want you to either figure out or look up, what if I asked you a rotation counterclockwise? So the opposite direction, counterclockwise, 90 degrees. So your XY, your initial point, what does it go to? And then what if it's a rotation counterclockwise of 180? And I'm going to put a star by that one because, and then I want you to tell me what's unique about 180. And then the third one for a third bonus point, rotation counterclockwise of 270 degrees. Okay, what's the rule? XY goes to what? Same thing up here. XY goes to what. What happens, what's the rule for all three of those, and then what's special about 180 or what's unique. All right? We're going to practice. See you guys on Monday.